I want to take the integral of this function this time. The cosine x, cosine of x, multiplied e to the x, multiplied by e to the x dx. Now remember this formula, which was uv v minus the integral of v times du dx. So now, remember, okay, so now we're going to set these variables within the equation equal to u du, which is the derivative of whatever you put in u, and then e to the x, sorry, what am I saying? dv, v, what was my v's that I used? dv, and then v. Now, if this is dv, the derivative of v, then this must be the original function. So this is the antiderivative. Remember, this over here is always the antiderivative. And that's important because that helps you decide what you're going to put in each one of these terms, right? Because if you want to put something in u, make sure it's something, or start from the bottom. Which of these terms has a more complex antiderivative? Well, it's cosine compared to e to the x, because look, I'll do it in another color real quick. Because look, the derivative of e to the x is equal to, what is it? Well, magically it's e to the x. The derivative of cosine, or the antiderivative of cosine, in this case, is sine. Sine of x is equal to cosine of x. Although not that tough, it's also not as easy as this. So you want to make everything inside the u value equal to this. Sorry, inside the antiderivative value equal to this, and the u value equal to this. So let's do that. I'm going to take fiery orange this time. Let's set u equal to, like we said, cosine, du, derivative of cosine, which is negative sine. Now, dv is the original term, or sorry, the derivative of the term, which is e to the x, and the antiderivative is also e to the x. Cool. Now what? Well, we just do this formula. Look, this is equal to u and v cosine x times e to the x, because remember, u and v over here, minus, because minus, the integral, that's huge, integral of v times du. So v is e to the x times du, which is negative sine x, dx. Now we can simplify because we have two negatives. We could turn this into cosine x e to the x plus sine the integral, plus the integral of e to the x sine x. Now, I mean, if you didn't have to worry about having two x values in your integral, you'd pretty much be done here. For example, if it was something like 2x, the integral of 2x times cosine of x, then the derivative of this would just be 2. Just be 2, because you would put this into u, and you would get this. du would be this, and you'd get rid of 1x over here. And then you could just keep that as your final answer. But because you have two x's, let's take the derivative again by parts of this part over here. So what you want to do is just do this. Bring down, okay, so now we're trying to take the integral, obviously by bringing down the initial term, of e to the x. Watch, it'll make sense in a second. Watch, I promise. E to the x dx. Now we run the same exact formula that we did up here. Set your u's, your dv's, and do this formula again. So watch. u is equal to, in this case, because we set u equal to the more complex term, so it's going to be sine of x. Sine of x du, well, that's cosine x dv e to the x and v also e to the x. Easy, right? So far, I mean, so good. So now this is equal to, I'm gonna do it in a different color. Now let's bring down this term, because remember, we're taking the antiderivative of this part. This part is still valid. It's still good. It's still solid. So we have to bring it down. So we write over here, cosine of x. This color actually hurts my eye. I'm not gonna lie. That rhymed. Now, minus, remember, we repeat this formula here because we're integrating again like we did up here. And we got this answer. Now we have to do this again. So now uv, what was our u over here? U sine x v e to the x minus, let me see if I'll be able to make space. The integral of, remember up here, v times u du, so v e to the x times du cosine x. Okay, I'll just write it dx over here. Now that we have this, notice one thing. E to the x cosine x is the same term up here, over here. This helps us because now watch what happens. Now if we just set cosine, I would just set this term equal to the original term because, I mean, that is what it is equal to, right? When you're writing these equal signs over here, it is ultimately equal to this original term, but sometimes we forget. But now watch. Cosine x e to the x minus sine x e to the x minus the integral of ex cosine x dx is equal to, just bring down the original term, and here we get the integral. Oh, that's terrible. Cosine x e to the x dx, right? But notice we have a minus sign, so what can you do here? What can you do here? Well, shift this to the other side and we'll get two of these terms. So we'll have, time for a color change. I like yellow. So cosine of x e to the x minus sine of x e to the x is equal to 2 times the integral, because remember we added this term and this term when they're the same term, so we'll get two of them, right? I hope you can understand that part. Sometimes they may be confusing, but I think it'll be fine. Dx. So we're here so far. Now just factor out an e to the x, because remember that you know how that works, right? Just factor it out. It's like just pull it out. It's weird sometimes how that works. So here, e to the x cosine, I know you could use parentheses, I like brackets. Cos x minus sine x is equal to 2 integration of e to the x cosine x dx. And now divide both sides by 2 over here as well. And now watch this. Let me just drag my screen down. And now your final answer is equal to, actually, you know what, blue is my favorite color. I'll write the final answer in blue. E to the x over cosine x minus sine x Now I'm going to switch colors. All over 2 is equal to, looks like a clown costume, is equal to the integration of e to the x times cosine x dx. This term, and whoa, and this term are the exact same. So therefore, through all that rigorous work and everything, looks kind of nice, doesn't it? Maybe it's just because I have colors and you don't, but I don't know. But look, here's our final answer. This is our final answer by double integration parts, which just means we did it by parts. And look, we're done. You know what? After all that work, I'm just going to sign my name on this. I have a really boring signature. And yeah, we are finished.